Welcome to CAD 130, and this is Project 1, and we're going to talk about projections in orthographic multiview. Really and truly, we have two main projections that we use, and if you've been, well, of course you've had to be in one of my classes to be able to move to this level. We've done orthographic multiviews, and you understand the basics. But we were using, during the whole semester, we were using third angle projection. And in the United States, that is the main projection that we use. And I've been doing this a long time, and basically that's the majority of what I've worked with. Now, first angle projection is more found in European states and some Asian countries. And I just want you to be familiar with the differences. Okay, I want to first start out by showing you the different axes and planes, and you pretty much know X, Y, and Z. I'll rotate this around, and this is just a typical way that this works. This plane right here, you all see it comes around through here. That is my XY plane, and is typically my horizontal plane. Okay, I'll look up here, and I've got on this side it's my YZ plane, and it's my profile plane. This plane that I'm clicking on here is my XZ plane. It's my frontal plane. So there's three planes. You got frontal, profile, and horizontal. Now, when you look at like the horizontal, I've got XY. You're asking me, well, how do you know that's an XY plane? Well, it depends on your axes. And you can see this axis right at this point that I'm clicking on. It kind of highlights. That's my Y axis. Okay? So if I turn this around, and this is basically what you're used to in the XY plane, this is my Y axis and this is my X axis. Okay? Now, the easiest way that I can explain that this plane right here is the XY plane is just think about this big sheet right here. Say it's a sheet of, let's just say it's a sheet of plywood, just to visualize this. You lay it down on those axes, and whatever axis, the two axes that holds that board up from falling down, is the plane that it's on. And you can see this XY, here's my Y plane, here's my X plane, and this sheet is laying right on top of those two. It's my XY plane. That's as simple as I can get it. Let's look at this one. YZ plane, here's my Y plane, here's my Z plane. That sheet, let's say sheet of plywood, is laying right on those two axes, and those axes keeps it from falling. And again, my XZ plane is the same way. Here's my X plane going across. Here's my Z plane, and that XZ plane is laying right on those two. That's how you get it. Okay, we'll move on just a little bit more. And like we were talking about projections, you know, in the United States we use third angle. We've already understood that. We've drawn multi-views in third angle. Now I want to show you the differences between first angle and third angle. And a good way to start out is I'm going to turn this thing around here like this, and of course I'll kind of move it just a little bit so you can see it. In this plane right here, in the frontal plane, in quadrant 1, it goes quadrant 1, quadrant 2, quadrant 3, quadrant 4. It's just like Cartesian coordinates, if y'all remember that. Your origin's right in the center. You go around counterclockwise, 1, 2, 3, 4. Now, one thing that you need to understand about first angle and third angle projections, they are complete opposites. Okay? In this plane right here, and it's the XZ plane. If it was the YZ plane or XY plane, it works the same way. Anything above this line going up in X would be positive. Anything going right of this line in Z for this experiment would be positive. So this is a positive plane for XZ. Both X and Z are all positive, the numbers in here. The third quadrant is everything and the x would be negative, and going downhill or going across the left, x would be negative. Anything going down from this axis would be negative, so our x and z both are negative. So this is negative, negative, this is positive, positive. Remember that. And it really makes a lot of sense when you're talking about first angle and third angle projection. Everything is completely opposite, other than one thing, the front view. Now remember, when we talk about the glass box theory, that glass box would encompass this whole area. This whole area would have a glass box in it. This whole area would have a glass box in it. And I don't want to get too technical with this, but and I want to show you just a little bit more in just a minute. But when I went to work, I've been in this field for over 17 years, and when I went to work, I had to take some first angle projection drawings and convert them to third angle projection. And when I first started that, I was just going through all the steps and just doing it manually, and I was mainly taught third angle projection just like most of you all. And trying to do it in first angle, it was very confusing, and some of the older colleagues there come over and said, let's just make this simple. Let's make this simple. Don't beat yourself up about this. This is totally easy. They said, if you know third angle projection, draw third angle projection. And draw third angle projection and just take and move some of your views. And I'll show you what I'm talking about here. Now remember, in first angle and third angle projection, everything is different, all but the front view. The front view in a first angle is the same as the front view in a third angle. Okay? So, real quick, I want to show you this picture here. This is this little part up here in an isometric view. Now come over here. This is third angle. This is what you're all used to. This is what we use in the United States. And like I said, when I first started working, I had to convert first angle into third angle, and I had to draw these parts. Well, I was trying to do first angle, and it was really confusing because all I ever really known was third angle. And my colleague told me, hey, draw it in third angle. So this is what we do. So here's our front. We project up for our top. We project over for our right, and we project left to make our left side, right? And don't forget one thing. On this, our horizontal plane runs right through here on this part. Here's our part sitting inside that glass box. Here goes our fold plane coming across here, and this line up here would be our horizontal plane, and when it folds open, there's your top. Okay? Just remember, and down here, look here. And this is first angle. Look at your front. They're identical. But remember, your horizontal plane, this part is sitting on top. So here's your horizontal plane going across this way, or your fold line, and that's your horizontal plane that folds out. So if I go back into this, right here would be that part in first angle projection, and this would be, it would be sitting in here for third angle, and it would project up to this. This one would project down to that. However, again, don't let this be confusing. First angle and third angle have the same front view, but they're totally opposite on the other views. Like the top view, and this is what they told me when I first started working. Hey, your top view, this is your top view in third angle. First angle, it's identical. Only thing I did was copied it and pasted it down and aligned it. Y'all see that? So my top is on the bottom here, but it's identical to the top up here in third angle. Now, look at my sides. Instead of third angle having the right side over here, my right side is on the left. It's identical. They're still right. This is still considered the right side in first angle. They look identical. They're just moved. They're just completely opposite. You remember what we talked about in Cartesian coordinates? The first, let me go back here and show you. The first quad is positive, positive. The third quad's negative, negative. They're complete opposites, right? That's where you get this from. So here's the right side. It's just opposite of what we're used to. Left side over here in the third angle is on the left side actually. In first angle, it goes over here to this side. So, like I said, don't beat yourself up on this. Do like I was taught. Draw it in third angle first, and just switch them. Take this one, move it over here. Take this one, move it over here. This top now goes down here to the bottom. You don't change anything. It just actually how that they align and how they fold out in the glass box theory.